Here's your 5-day, and here are the answers. Let me know if you have any questions about them. So today we're going to be having a look at reciprocal functions and how to calculate certain values for them, and some new Pythagorean identities. So the reciprocal functions are secant, cosecant, and cotangent. Secant gets shortened to sec, and it's defined as 1 over cos theta. Sec theta equals 1 over cos theta. So this is why they're called reciprocal functions. Cosec theta is defined as 1 over sine theta. And cot theta is 1 over tan theta. So it can be a little bit confusing, but with sine and cos, the first letters swap round. So the one that begins with an S goes with the one that begins with a C, and vice versa. And then cot and tan both have T's in. That's just a way to remember which one is which, because it's easy to get confused. And they're all undefined if whichever thing is in the denominator is equal to 0. Now, you should know that x to the power of -1 is equal to 1 over x. That's not the case in trigonometry. We don't write cos to the power of -1 equals 1 over cos theta, because that gets mixed up with inverse cos. So just be really careful there. We don't ever write it. Something that we'll be using later, a reminder, this has come up in our other lessons so far, but tan theta equals sine theta over cos theta. What we can use that with is if we say 1 over tan theta equals 1 over sine theta over cos theta, then cot theta equals cos theta over sine theta. Okay, let's have a look at some examples. So cosec 200, will that be positive or negative? So for this, we need to consider sine of 200. It's just 1 divided by it. So if sine 200 is positive, then cosec 200 will be positive, and similarly with negative. Now we can think about the graph, or we can think about the unit circle. So my graph, 200 is about here. That gives me a negative value. On my unit circle, remember I start at my positive x-axis and move in an anti-clockwise direction. This would be 180, this would be 200, and we know that using cast, sine is negative in that quadrant. So either way, we know that sine of 200 is negative, so cosec 200 will be negative too. Okay, we need to be able to work out exact values of the reciprocal functions as well. Now, 210. So sec 210 equals 1 over cos of 210. We need to think about what cos 210 is. So it lies here, or if I've got my unit circle here, and I've moved, if this is 180, I've moved 30 round from 180. So cos is going to be this, cos of 210 is going to be the same as cos of 30, but negative. And that's a way to think about it using the graph. Now, to remind ourselves what cos of 30 is, we can use our equilateral triangle. That's why I've got that here. Remember, we can split our equilateral triangle in half. The side length here is 2. This is half of that, which is 1. Using Pythagoras, this is root 3. This angle here is 30 because my equilateral triangle has angles of 60 and this angle has been bisected. So cos of 30 is adjacent, which is root 3, over hypotenuse, which is 2. And here, remember, I'm taking the reciprocal of a fraction, so that's just effectively flipping the fraction. So sec 210 equals negative 2 on root 3. Or if I want a rational denominator, negative 2 root 3 over 3. Let's have a look at another one. So cosec of 3 pi on 4. Cosec equals 1 over sine. So we're going to be considering 1 over sine 3 pi on 4. 3 pi on 4 is here on my graph, or it's in the second quadrant of the unit circle, so sine is positive. It's going to be the same as the value for sine of pi on 4. Using my isosceles right-angled triangle, which has these values, I know that sine pi on 4 is opposite 1 over hypotenuse root 2. And then I've got 1 over a fraction, so I take the reciprocal of the fraction by flipping it. And so cosec 3 pi on 4 equals root 2. Pause the video now while you have a go at these questions. So there's some other identities that you will find useful. 1 plus tan squared theta is identical to sec squared theta, and 1 plus cot squared theta is equal to cosec squared theta. Now, you might need to know where these come from, and in fact it's useful to know where they come from in case you forget them. So if we go back to our original Pythagorean identity, which is sine squared theta plus cos squared theta is identical to 1, then I could divide everything by cos squared theta. So that gives me sine squared theta over cos squared theta. That would be tan squared theta. Cos squared theta over cos squared theta, which is 1. And 1 over cos squared theta. 1 over cos theta is sec theta, so 1 over cos squared theta is sec squared theta. Now, similarly, I could divide everything by sine squared theta. So I get sine squared theta over sine squared theta is 1. Cos squared theta over sine squared theta, that's this, so it's cot squared theta. And then 1 over sine squared, 1 over sine is cosec, so 1 over sine squared will be cosec squared. Now, I find it easy to get these mixed up, what goes where and does the one go with the tan or does the one go with the sec and so on. So what I tend to do when I'm using them is I just start with the original Pythagorean identity that I know and then go through this process quickly in my head. I do know that the C1 and the C1, so cot and cosec, go together, so therefore the other leftover bit, tan and sec, must go together. But to make sure I get the one on the right side, I think it's easiest just to derive them. Now, we can use these to prove equivalences or prove other identities. So have a read of this. Now, my general recommendation is start with the most complicated side, but both sides are pretty complicated here. However, I can see that the left-hand side is the difference of two squares. Now, my cosec squared theta, if we look up here, equals 1 plus cot squared theta. That's going to be useful because I've got cot squared theta here, cot squared theta here. These two cancel each other out. So now I have this, which has certainly got simpler than it was before. The reason this bracket's disappeared is because it's equal to 1. When I multiply by 1, my first bracket will stay the same. Now I can rewrite cosec squared theta as 1 over sine squared theta. And I can rewrite cot squared theta as cos squared theta over sine squared theta. The reason I'm doing this is I can see I need cos squared thetas in the thing that I'm aiming for. Put it into one fraction. Now I've got the right numerator, I need to change my denominator. Using the original Pythagorean identity, I can say that sine, so I'm using this one, but I've rearranged it, sine squared theta equals 1 minus cos squared theta. And that's what I needed. Another example. This time I'm going to start with the right-hand side. Expand the bracket. Rewrite the sec squared. Sorry, this one here. It's 1 over cos squared. I can simplify and rewrite this. Sine squared theta over cos squared theta is tan squared theta. Now, I want cos and sec, and I've got sine and tan. But you can see cos and sine are related in this one, sec and tan are related in this one. This should say identities, not inequalities. And so then this 1 plus this negative 1 cancels, and I get sec squared minus cos squared. If you had started with the left-hand side, you might have been able to get to the right-hand side, or you might not. Sometimes with these kinds of questions, you might hit a dead end and then you need to try something else. But it's preferable that you just start with one side and you manipulate it until you turn it into the other side, rather than doing the same thing to both sides of an inequality. That ends up getting quite messy, and often you can make mistakes and do things that are mathematically incorrect. So there's plenty of practice and you'll get better at spotting things. The more you use these identities, the more readily they'll come to your mind when you're working through these questions. So there's 6 questions here. Practice them. Let me know if you have any questions. You obviously should know if you managed to get the correct answer. Also, I have some more questions of these, so if you'd like some more practice, do let me know. Thank you.